Hello, and welcome to SolidCAM Professor. My name is John, and in this video I'm simply going to show you how easy it is to program with SolidCAM, simulate toolpath, and finally generate G-code. Now before I get started, I should note that this video is only meant for viewing and is essentially just an introduction to SolidCAM using some of our 2.5D milling technologies. With that said, it's not one of our tutorial videos that's intended to help you practice using the software. So you'll see that many of the explanations normally provided will not be included here. Alright, now I'll get started with my quick introduction to SolidCAM. Let's take a look at my screen. First of all, as you can see, I'm working in SolidWorks. I have my model on the screen, and the next thing I want to do is create toolpath to machine this part, resulting in a finished product exactly as I see it here, otherwise known as my target. Since I'm ready to machine, I'm ready to start SolidCAM and create the CAM part. Now, a key thing you should know is that SolidCAM provides a seamless single window integration to SolidWorks, so all your CAD and CAM is done without having to leave the SolidWorks environment. In addition, the created CAM part will provide full associativity to the SolidWorks design model. So, that means if I make any changes to my model today and open the related CAM part tomorrow, SolidCAM can automatically update my CAM project and my machining operations accordingly. In the SolidWorks main menu, I'll click SolidCAM, New, Milling. The New Milling Part dialog box is displayed. Now, I customized my CAM settings to do two things. First, my CAM project will be created using the internal mode by default. This mode will store the SolidCAM data inside my SolidWorks part file. Since I'm the one who built the CAD model and will subsequently build the CAM programming, it makes sense for me to work using this internal mode. You'll see that the CAM part name automatically defaults to the SolidWorks part name plus a milling designation, since this is a milling project. Because my SolidWorks part was built with millimeters, you'll see that my units of measurement automatically default to metric. When using the internal mode, I know that this setting cannot be changed. Now, when I click OK, my CAM part will be created. After it's created, you'll notice some actions being performed in the background. SolidCAM is automatically defining the CAM part according to my requested specifications, which was the second thing I asked to be performed in my CAM settings. After the automated CAM part definition process is completed, SolidCAM prompts me to let me know that I can now start adding operations. But before I add any milling operations, you're probably asking yourself, what exactly did SolidCAM just do? Well, there are some important definitions that SolidCAM needs to know before we can calculate toolpath, perform any simulations, and finally output G-code. These definitions include the post-processor I'll be using to output G-code for my CNC machine, the coordinate system or origin for all my machining operations, and finally the stock and target models. In the SolidWorks graphics area, the coordinate system is shown on the top center of my model box, and it looks very similar to the SolidWorks reference triad that you see in the bottom left corner. The stock is represented graphically by the gray bounding box around my model, which was then defined as my target. Now that SolidCAM knows all these things, I can start adding my operations. And in doing so, I'm going to show you just how quick and easy it is to program this part using SolidCAM. Now, in looking at this part as a whole, I know I can complete the programming in basically 4 2.5D milling operations. First, I want to perform a face milling operation on the top surface. I'll go to the SolidCAM Manager on the left, where I can add the first operation. I'll right-click Operations, Add Milling Operation, and select Face. The operation dialog box appears and enables me to define the parameters that are specific to the machining technology. You'll notice that all my machining operations will follow this same type of workflow, as shown in the tree here on the left. The first thing I need to do is define the machining geometry. This will inform SolidCAM what areas of the model I want machined. So first on the list is of course the geometry page, where I'll click the New button. The default selections are mostly used. In the base geometry section, however, I'll click the drop-down and select Target from the list. Now, I'll simply click OK to confirm the geometry definition. Moving down to the Tool page, I have to define and/or select the tool I want to use to perform the machining. I'll first click the Select button. Now for this CAM project, I set up a tool library ahead of time to cover all my operations. So rather than defining new tools, I'm just going to import them. To do that, I'll click the Import Tools button. My default library loads, and I'll click the Import All Tools button at the bottom left corner to add them to my Part Tool table. I'll click OK, select my face mill from the Part Tool table, and then click the Select button to choose the tool for the operation. Next, I have to move down to the Levels page to tell SolidCAM on what Z levels to start and end the machining. These Z levels can be picked directly on the model. First, I'll define the upper level, which is the top of my stock in this case. Then I'll define the face depth, which is the top face of my target model. Next up, I need to tell SolidCAM how I would like the machining performed based on the face milling technology. So I'll move down to the Technology page to define the technological parameters. I want to use the option of 1-pass for my technology, and the remaining default parameters are suitable for facing this part. The last parameters page most typically used is the link page. For this operation, however, I'm not going to define a lead in or lead out as it's not necessary. Now that I'm finished with the operation definition, I'll simply click the Save and Calculate button to add the operation to the CAM tree and calculate the toolpath. Now for this particular video, I'll simulate the toolpath for all my machining operations after the part programming is completed. Next, I want to machine the outside shape. For that, I'll use a profile operation. Again, I'll right-click Operations, Add Milling Operation, and select Profile. I'll click the New button on the Geometry page to define the machining geometry. In the SOLIDWORKS graphics area, I'll pick on the outside contour of the model to start the chain definition. I'll then select Auto Constant Z to close the chain, and then click Yes to accept the chain selection. To confirm the geometry definition, I'll click OK. Now I'll select my tool by first switching to the Tool page. I'll click the Select button, choose my end mill from the Part Tool table, and then click Select to confirm the use of this tool for the operation. Switching to the Levels page, I'll define my upper level first, which is the top face of my target model. Then, I'll define the profile depth by picking on the bottom edge of the outside contour. On the Technology page, I'll use the default technological parameters. The tool is set to mill on the left side of my geometry definition at a constant depth. Lastly, I want to switch to the Link page to define the approach and retreat of the tool link movements relative to the profile machining. I want to perform a 3mm arc lead in, and I'll set the lead out to do the same. Finally, I'll click Save and Calculate to add the operation to the CAM tree and calculate the toolpath. Next up, I'm going to define a pocket operation to perform the machining of the pocket. I'll right-click Operations, Add Milling Operation, and select Pocket. I'll click the New button to start the geometry definition. I'll pick on the pocket contour, and then select Auto Constant Z to close the chain. I'll accept the chain by clicking Yes, and then I'll click OK to confirm the geometry definition. Next, I'll switch to the Tool page to choose my tool for the operation. Switching to the Levels page, I'll define my upper level first, which is again the top face of my target model. Then, I'll define the pocket depth by picking on the lower surface of the pocket. On the Technology page, I'll again use the default settings. My tool will perform the cutting with a contour strategy and will overlap 50% of its diameter with each step over. Lastly, I want to switch to the Link page to specify how I'd like the tool to enter the material. In the ramping area, I'll choose helical from the drop-down list. The pocket operation is now defined, so I'll click Save and Calculate to add it to the CAM tree and calculate the toolpath. Now, the last thing I'd like to do is have SolidCAM perform the drilling of the holes in the four corners of my part. To add the operation, I'll right-click Operations, Add Milling Operation, and select Drilling. To start the geometry definition, I'll click the New button. Using the default selections and filters, all I have to do is simply just pick on the top face of my target model. SolidCAM finds all 4 holes on the selected surface and uses their center points as drill positions. I'll click OK to confirm the geometry definition. Next, I'll select my tool just as I've been doing. This time, I'll choose my drill from the Part Tool table. Next, I'll define the levels. First is the upper level, which again is the top face of my target model. I'll then define the drill depth by picking on the bottom face of my target model. For the depth type, I'll select full diameter because I want the full diameter of the tool to reach the defined drilling depth. Lastly, I'm going to use the default technological parameters. Now that the drilling operation is defined, I'll click Save and Calculate to add it to the CAM tree and calculate the tool path. The part programming is completed at this point. Now, the next important thing I'd like to do is simulate the toolpath prior to generating G-code and finally cutting this part on my machine. I'll click the Simulate button to display the simulation control panel. Since I haven't yet simulated any of my operations, I'd really like to simulate the toolpath for the CAM project in its entirety. To do so, I'll highlight all the operations by selecting them. This will start the simulation from the beginning. Or I can simply just click the operations header. For this example, I'll use my Solid Verify mode so I can see the tool moving through the solid stock material. The simulation looks great. Now I know I'm ready to cut this part on my machine. But first, I need to generate a G-code file. I'll exit the simulation and operation dialog boxes. Then, I'll go to the SolidCAM Manager and right-click Operations, G-code All, Generate. The generated G-code opens in Notepad, and I'm now ready to machine this part on my 3-axis Haas. So there you have it. As you can see, it's quite easy to cam a part and generate G-code with SolidCAM. Thanks for watching. For more great SolidCAM Professor videos, visit the Professor page at www.solidcam.com.